Welcome geometry students. This is our video on the triangle inequality theorem. So take a second to read the triangle funnies. They're a little punny, actually. I thought they were entertaining, so I thought I'd share them with you. Let's go ahead and talk about the triangle inequality theorem. Here we have two sets of three segments, and what I'm going to try to do is make a triangle. So I'm going to take this longest segment, I'm going to put it at the bottom, make that the base of my triangle. I'm going to take this red one, I'm going to rotate it, see if I can put it corner to corner there, and we'll take this third one. Let's see if I can make a nice happy triangle here. Sure, looks like I can. Looks like I just have to line it up, and sure, yes indeed, I can make a triangle. Specifically, it looks like it's scalene because those are three different lengths of sides, and it looks like it's probably obtuse. This angle right here does look to me like it's probably obtuse, but I'd have to actually measure it. Can't trust your eyes, remember? So that one makes a triangle. Okay, let's try this other one. So put my green one here. Let's put my red one here. Uh-oh. Well, look at that. That is not going to work. That's not going to work at all. So what's different about my two sets of segments? All right, so how can you determine if three lengths can make a triangle? Well, the triangle inequality theorem states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. And I have three inequalities here that go with a color-coded triangle. The length of AC and the length of AB added together must be greater than the length of BC. The length of AC and BC added together must be greater than the length of AB. And finally, AB plus BC must be greater than AC. So that's the triangle inequality theorem. That's what it tells us. Keep in mind that while you can go in that direction, talk about the sum being greater, you can also state that the difference between two sides. So if I was to take, let's see, if I was to take AC and subtract AB, that has to be less than the length of, you guessed it, BC. Now, why does it have to have an absolute value in the problem? Well, keep in mind that in any other triangle, or in any triangle, one of these may be larger than the other. So it's the absolute value of their difference that must be less than BC. So let's write our other two inequalities. You can even pause your video and try it yourself. But I'm going to go ahead and keep going. So the next inequality I have, let's say, we'll go to, let's say, how about AC minus BC. That difference, the absolute value of that difference must be less than, you guessed it, AB. And then there's one more inequality. Can you figure out what combination of sides has to go in that inequality? We've done AC minus AB. We've done AC with BC. What haven't we done yet? Well, we haven't done AB minus BC. And that difference must be smaller than AC. So there's two relationships in every triangle. You can find the range of lengths of the sides. Let's try some examples. But first, let's look at an extension of the triangle inequality theorem. In any triangle at all, like the one we have here, the smallest side of the triangle is opposite the smallest angle. And what that means is I want you to look at the smallest side. A is the smallest angle. They are opposite one another. So if you can start from the angle and draw an arrow, an imaginary arrow, well, for you it's imaginary, for me it's right here. So the imaginary arrow that says this is the smallest angle, so this, BC, is the smallest side. The largest angle, the largest side is opposite the largest angle. So again, in this one, it looks like that's going to be the largest side is AC and the largest angle is B. The side that has a length between the two lengths of the other sides is opposite the middle-sized angle. So in this case, that would be AB, and that's across from angle C. when we label the sides of a triangle, we do it with lowercase letters. So this one, for example, let's just do it in black so we don't get confused. This one, for example, is going to be side little c, side little c. This one is going to be side little b, and this one over here is going to be side little a. So if I'm listing the sides in order from least to greatest, I start with the one that's opposite the smallest angle. That's A, so that goes first because that's the smallest. That is smaller than the one that's across from the middle-sized angle, which is C. So that comes next. And then finally, the only other one we have, which is B, which is across from the largest angle. So from least to greatest, the sides are A, then C, then B. So how can we apply this to problems that we have to be able to solve in geometry? Given the angle measures, put the sides of the triangle in order from least to greatest. So if we actually have the angle measures, I don't even need to be able to see my triangle. Now we already did this example on the previous page, exact same problem right here. But now we have 3 angle measures, and I want you to remember, and when we do this, that this is not going to be drawn to scale. And what that means is that it isn't actually going to have sides that are in, in this case, angles that are measuring exactly what you see up there. Okay, the angle that you look at for angle B right here, probably not 111 degrees. Okay, because I didn't draw it that way. So in this one, I'm going to be able to say that the angles, we want to put the sides, in order from least to greatest. So if angle A is 37, B is 111, and C is 32. So I can say that side C, which is opposite angle C, must be the smallest. So that goes first. Then side A, which is opposite angle A, is going to be the next smallest, followed finally by B. So that's sides C, then A, then B from least to greatest. How about the next one? On this one, what do you notice? I have measure of angle B, 57 degrees, and the measure of angle C, 48 degrees. But I imagine you're probably saying to yourself, well, I can't finish this. I don't have the third angle. How do I find the third angle on that triangle? Well, you use the angle sum theorem. The 3 angles of a triangle always add up to 180. So take the 2 that you know, add them together with a variable for the third, and set that equal to 180. And then solve your equation. 57 and 48 is 105, I believe. So 105 plus x equals 180. Subtract 105. And therefore, my missing angle is 75. And now I can actually answer the question. So the smallest of my 3 angles is C, so that is the smallest side. The second smallest is B. And finally, the last one, the one we found, because x actually represents the measure of angle A, that's the biggest one for this problem. Different type of problem, given the lengths of the sides, put the angles of the triangle in order from smallest to largest. This is exactly the same idea. So again, I am going to look at these and I'm going to again name the angle and the side based on the fact that they are opposite one another. Like so. So if 6 is the smallest, then angle A is the smallest, followed by 8, so that's angle C, and then finally angle B. Don't get thrown by the decimals. It means absolutely nothing in terms of how we do the problem. Angle A is still the smallest because 4.8 is the smallest number out of the 3 side lengths that we have. Angle B is second, with angle C third. Next, we're going to find the range of the third side of a triangle when you're given the 2 side lengths. So with the 2 side lengths that are given, and that is a typo there. The word lengths has an N in it. Sorry about that. Okay, so we have 3 and 7. So what we're going to do to figure this out is we're going to find the difference, okay, the absolute value of the difference there, and the sum. Okay, don't need the absolute value on that one because that one will always be positive. So let's go ahead and find that. So 3 minus 7, the absolute value of that is 4. 3 plus 7, that's 10. So the range for this particular problem is from 4 to 10. Okay, how about the next one? 11 minus 6, which I don't need to use absolute value, but I'm supposed to, so I understand the concept here. So the difference of those two sides is 5. And then the sum of those two sides is 17. So the smallest to the largest would be 5 to 17. Now, can the third side of this triangle actually equal 5? Well, no, because look, you don't have an or equal to on your inequality symbol. So it has to be bigger than 5. 5.1 would work. 16.999 would work, but not 5 and not 17. Determine if the three numbers given can form a triangle using the inequality theorem. So on this one, you're using what you've now learned to figure out if you can have a triangle with that third side. So we have 5, 8, and 13. So first of all, let's think about the order here. I'm going to take the two smallest, 5 plus 8, that equals 13. The sum of two sides must always be larger than that third side. So this is not a triangle. 12, 5, and 16. Okay, how about 5 plus 12? So again, I'm taking the two smallest. That equals 17. 17 is indeed greater than 16. Therefore, this is probably a triangle. Okay, what about the difference? Well, 16 minus 12, that equals 4. And 4 is less than 5. So yes, this is indeed a triangle. Finally, we have 5, 12, and 13. Well, let's try 5 plus 12. That equals 17. And 17 is indeed greater than 13, so that's good. And let's do 13 minus 12, and that's 1. 1 is indeed less than 5, so that's good. And yes, this is indeed a triangle. Let's finish out with an application. So we learned it, now we need to apply our knowledge. Two roads meet at an angle of 50 degrees at point A. A third road from B to C makes an angle of 45 degrees with the road from A to C. Which intersection, A or B, is closer to C? So we are comparing the lengths of AC and BC. So that's a question mark there in between. So which one is smaller? That'll tell us which is closer to C, whether it's A that's closer to C or B that's closer to C. So the first thing we're going to do is you'll notice we have two of the angles and we don't have the third one. So take what you know, we'll call that X. Let's take what we know, X plus 50 plus 45 equals 180. Let's add our like terms together, so it's X plus 95 equals 180. Well, if 90 plus 90 is 180, then that X must equal 85. Just use a little logic there. Sometimes it's a good idea to turn on that part of your brain rather than writing it out as a solved equation, but I can double check and go back. Yep, it's 85. So B is clearly the largest angle. Let's go ahead and put that in here. 85 degrees. Okay, so at that point, we want to know which is closer, A or B, to C. So we need to know which one of these two lengths is longer. So let's look at the angles. 85 degrees is across from AC, whereas 45 BC. Oh, I want BC. 50 degrees, is across from BC. So that means that BC is definitely smaller than AC because it has the smaller angle across from it, opposite it. So if BC is smaller, that means that B is closer to C. So B is the intersection that answers the question. And that, my friends, is it. Hope you enjoyed it. Make sure you ask any questions you have of your teacher, and I'll see you guys in class.